All right. Yes. So.
Yeah, video is good. Yeah.
Fine. We have the answer now.
Yes, sir. It is mine is coming 9973.
Nautical miles. That's right. So, what can you say about these points? So, if you look at these 2
Sir,
points,
these
they are
both
definitely in
points-
different hemispheres, and they have different
Different
longitudes,
hemispheres.
right? So, what connection do you
Yeah.
find here?
So first of all, seeing to this, I just went through the longitude part. The longitudes were different and were in opposite in sense. So that is why I added both of the meridians,
Yeah.
and thus I got them longitudes. So I got it 180 degrees. So
Basically, you
came
add
to
the
what,
longitude,
that
they
is-
add to form 180, right? So basically, this is 5 plus 5, 10. This is going to be 60 minutes, and this is going to be 971. Right? And this is 60 minutes will add up as a degree and will form 180 degrees. And one is east, other is west. So our condition is kind of satisfying. Therefore, we can say these 2 points, they lie on different hemisphere. Different hemisphere because one is on the north, other is south, and then they are on a meridian, and it's anti-meridian. How is these points different from the points which we just did before?
that points were both in the same
Hemisphere.
like
They are
in
the same
northern
hemisphere,
Yeah.
but here it is a different hemisphere. But all these points are on a meridian and anti-meridian. So which view is the best view to draw?
The side view, the one here. I'll take the 2 meridians at the extreme ends.
That's right. So the 2-dimensional side view is the best view to draw. So this is basically the side view, where we take one of the meridians as 135.35 and the other will be 44.25. It's completely up to us. So we'll take this meridian here. We'll take this as 135 degree 35 minutes east. Now, is it really possible? Can I take the meridian to my right as 135.35?
To your
East.
right.
Yeah, that's what I'm taking. The one to the right is 135.35 east. So, what direction is this? This is the east. This is west.
Eastern
Because Earth is
direction,
rotating
yeah.
from west to the
West.
east and north and south.
Yeah.
So, I've taken here 135.35 east. What if I change this and what if I put here 44 degrees 25 minutes west? So, on the eastern direction, we have a western longitude. So can I take this meridian as west and this as 135.35 east, or should it be the other way around where I wrote 135.35 east here first and this one over there? The question is, can I take a western meridian towards the east and an eastern meridian towards the west? Is this representation correct?
We can take, no problem.
Or the other way around? Can I take 135.35 east here and
We can take that also here.
25 minutes west. Yes, so it doesn't really matter. Your western meridian can be on the eastern side, and eastern meridian can be on the western side. So in this case, you can see you are looking more from the anti-prime meridian side. That is why you have the eastern hemisphere to your west and western hemisphere to your east. But it can be on east. So this is one thing which confuses people, that why have I taken west here when it is east? This has nothing to do with your meridians. This is only dependent on the directional rotation of the Earth. As I told you yesterday,
Direction.
this will change only if the Earth changes its rotation, which is not going to happen. Therefore, this depends upon where your prime meridian and anti-prime meridian is. Since you're looking from anti-prime meridian side, your west is to your right, your western hemisphere is to your right. That's all. Right? Perfect. Yes. Now, what about the parallels of altitude? 35.57 north, which is say here.
Yeah.
And 22.10 south. Yes, so let's mark the point here. The point of intersection of 35.57 with 135.35 is right here. That's what I said. Be very careful to mark the points. If I reverse this point is going to come here, right? But this is the point H. And this is going to be the point I, intersection of 22.10 with 44.25. Yes, so what can you say about these points? They are on a meridian, anti-meridian, and they are on different hemispheres. Therefore, if a point is on a meridian and it's anti-meridian, the shortest path will be through the
Nearest pole.
Nearest pole. So which of these is the nearest pole?
And we'll calculate the angles from like this way and this way around. So
Yeah, you see that I
whichever
told
angle
yesterday
is
about that
less.
confusing thing. The question which we had yesterday, it was pretty clear that North Pole was a nearer pole. But from the looks of it, over here, it can be either north or south. From the first look, you probably might not be able to define it because it's kind of nearly 35 to 57, and these latitudes are pretty much closer that they look exactly opposite to each other. But how do you generally find that out? By connecting these points to center of the earth.
Center of Earth.
Right? And this is also connected to I. And we know that this H latitude is called as 3557 because the angle
35
made by
degree
it
57.
is 35 degrees 57 minutes.
Yeah.
Perfect. And this is called as 22 degrees 10 minutes of parallel latitude because this angle is 22 degrees 10 minutes from the equator measured towards
10
the sun.
minutes.
Right? Now what angles are we trying to look at? We are trying to look at a distance of H through North Pole
To I.
or from H
To I.
through South Pole to I. Two
To I.
different cases. So if you look at the first case here, if I want to find the angular distance H N I E I have to basically initially I can measure the angles and then I have to convert angles to distances. So the angle which I'm looking at, the corresponding angle I'm looking at is right here.
Yes.
Right?
Yeah.
So how can we find this angle basically? So this entire line is 180. If you subtract 180 minus 3557, you will get this smaller portion here. And then you simply add 20 to 10 to it. Right? So it's 180
Yeah.
minus 3557.
Yeah. So it was coming 166 degrees 13 minutes.
166 degrees 30 minutes. How will you do it without calculator?
With I did it with calculator. Without calculator, it's 180.
Yeah. So how is it done?
57, 10, 3, 9, 5,
Yeah, you get the same answer.
4. Yeah.
Yeah, but basically we have 0 minutes here, so we have to probably take one from the hours, the degree session. So 1 degree taken from here will become 60 minutes. And now it is 60 minus 57, which is giving you 3 minutes. So since we took 1 degree out of 180, that's going to become 179. And 179 minus 35 is 145.
Yeah.
Right? So this alone is 145 degrees. 3 minutes. Now what do we have? We have to add 22 degrees 10 minutes to it. Therefore, this total angle is going to be 167 degrees and 13 minutes. Is that correct?
And 166 it was coming for me. 140.
Oh, sorry, that's 166 because 9 minus 5 is 4 here, correct? This is 4.
Yeah.
4 degrees. So it's
166 degree.
13 minutes. Be careful with the calculation. If you have the calculator, it's fine. It can help you. Therefore, this angle is equal to 166 in 13 minutes and the corresponding angular distance is this. And since we know that the complete circle is 360 degrees, what is going to be this angle?
360 degrees minus of 166 degrees 13 minutes.
That's it. 166 degree 13 minutes. You can use your calculator here. That's going to be...
It is 193 degrees 47 minutes.
Yeah, 193 degrees and 47 minutes. Right? So looking at both these angles, you can see that this particular angle, 166 degree 13 minutes through North Pole is the shortest, and therefore North Pole is the nearer pole. So be very careful when you choose the nearer pole, especially when you have latitudes almost very close to each other. That's when this problem happens. Right? I think there's something wrong with the video. It's just kind of flickering.
Yeah, flickering, yes.
Alright. So, therefore, we are looking at a degree change of 166 degree 13 minutes. So how will you convert that to minutes? 166 into 60 plus 13.
13 minutes. That will give me 9973.
Yeah, plus 1 3. So just
Yeah.
9973 minutes. Now we have to take a pause here, and then we have to look whether we are measuring it through a great circle. So you can see that when I travel from H to N and N to I, initially I'm traveling through the great circle 135 degree 35 minutes east, and then I'm traveling to the part of great circle which is 44 degree 25 minutes west meridian. Therefore we are measuring it along a great circle, and therefore I can apply the conversion. 1 minute is equal to 1 nautical mile, and that is 9973
Nautical miles.
So it's a very similar type of question. In the previous question, the points were on the same hemisphere. Now it's on different hemisphere. That's all.
Yeah.
Alright? Happy with this question?